Okay, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1000. Hopefully you guys have had a good week and are ready to jump into it. So the main agenda for today is to actually go through the quiz that you took on Monday. Make sure you understand the answers, why those guys are the answers, and all that good stuff. Let me share my screen here. I suppose even before we start, there are just some things that I do want to make sure that we are aware of. So I've sent a couple emails out at this point. I just want to, someone else is trickling in here. I just want to remind you that one, you should remember to fill out the doodle poll if you haven't already. So as mentioned, I was going to, Ram, you have a question?
Yeah, what if the dates that you give for the study session, like it doesn't like adhere to our schedule? Like I can't make it to any of the dates you gave, like on Friday specifically.
I don't know. I think I will record it, so I guess you can watch the recording, maybe. But yeah, it'll lose some interaction for you, I guess, but that would be unavoidable. Fridays are kind of the only days I can do it based on my schedule. And but yeah, so that's about study hall. And actually, the more interactive it is, the better. Of course, I'll go through some strategies and things of that sort. But a lot of times when you talk about how things can work in theory, people don't know how to apply it in their actual lives. So I will really like it if you show up and you can ask questions about your personal situation, maybe without giving away too much information, just about your personal struggles with time management or studying or all that good stuff. So the main deal is to just talk to you guys about good study habits, how to apply them in a practical sense, and maybe even have some real world examples. And this is mostly based on things that I've been talking to students with in office hours, general trends that I've been seeing over the past few years of teaching, etc. Just want to make sure that we are, we kind of know how to go about doing better in the class, maintaining our standing in the class, improving our standing in the class, and just keep going. As well as, this semester and the end of last semester was pretty crazy with everything moving online. So it's a new environment. And so it's more important than ever that we have good self-study skills because we're not meeting in person. So those are the kinds of things I would talk about. And the more you show up in real time, the better, I would think. But if you cannot make it, I will record it. So be sure to fill out the doodle poll. You have until this evening around 5 p.m. And whatever is winning at that point, I will choose that at the date. I checked a few minutes ago, and it seems like tomorrow at 2:30 is going to be the winner. Yeah, but that could change if a lot more people actually fill in the poll. So I think by the amount of people who have filled in the poll, it's about 2 full classes worth. So about half of my students have filled in the poll so far. So I would encourage the other half of you to actually fill that out. Okay, so be sure to do that. Another thing I would say, and this is just to mention, last day to drop a class is tomorrow. So if we actually have the study session tomorrow and there's anyone still on the fence about whether or not they can handle the class this semester, the study session, the study hall session would actually be very useful to that because we'll talk about what it would take. So if you're not doing so well and you're kind of on the fence and you want to know, is it worth me sticking around? Can I actually pull it off and get a better grade, the kind of grade that I would want? I'm pretty much going to talk about how to improve to the grade you want, what it's going to take, and then you'll be able to have a pretty clear view of, okay, if I want this grade, this is kind of how much work I'd have to put in. I think I can do that, so I'll stick around, versus, okay, yeah, it's possible, but you know, my schedule is just not going to allow for it this semester, so I'm out. Right, so you can make a better informed decision if we happen to have the session tomorrow. Another possible date is next week, Friday, in which case it would be too late for you to make that decision. So it's very important, especially if you are slightly on the fence. You probably want to make sure you go to the Doodle Poll and vote for some time tomorrow for this thing to take place. That being said, even after I record it, it will probably take a couple hours for it to actually be posted, because for the video to process, for me to download it and then upload it, actually takes some time. So just also be aware of that. So if you miss it, it'll probably be in the evening on Friday before you actually can actually see what went down. Another thing I would say is you should just pay attention to exam schedules, including the final exam schedule. Right? All my quizzes and tests are scheduled already. They've been scheduled since the first day of class. Make sure you go over the syllabus. You know when each quiz is taking place, when each test is taking place, and when the final is taking place. I sent out an email with the final exam schedule as well. Yeah, the Doodle Poll link is in the email I sent out today as well as earlier. Yeah, should be the same link. So I also previously sent out the final exam schedule a while back. That was more than 2 weeks ago. So make sure you go over that. Make sure you actually know how to find that, because, you know, final exam week is usually crazy, whether or not you're in person classes. So you definitely want to start strategizing and planning out your time, knowing when all your finals are occurring, which final is occurring first, which finals you'd have to do the most work for, and you need to know by what date you will have to be able to show that you have the right stuff. So make sure that you are paying attention to the schedule. Remember, as I mentioned, lack of awareness is a very big issue. Do not suffer from it. Make sure you're aware of when you need to be ready for what. So make sure you know my class schedule, my exam schedule. Make sure you know the exam schedule for your other classes. And in fact, I think it would probably be a good idea. I did send you the link to that, but it's probably worth me showing you. Okay, so here you're seeing my browser. So this is just a regular Google. If you Google Fordham final exam schedule, press enter. It'll take you to this page. It's usually going to be the first link. These are the other final exam schedules pages. So you can click on that. And usually this page is filled out even before classes start. This semester, though, it was filled out a little bit late, 3 weeks ago, a month ago, or something like that. But you can see here, fall 2020 says preliminary final exam schedule. They always say preliminary because they want to be able to change if necessary. But usually by the time they post this, it rarely ever actually changes after that. So you can go here, and I sent you the link to this already, and so you shouldn't have to do that. But if you lost that link or you want to know, you can just literally Google Fordham final exam schedule and you can find it. That being said, our class is Mondays and Thursdays, 2:30 to 3:45. So that's this here. So as you can see, our final will be on December 14th at 1:30. So that's when you have to be ready for our final. Okay. So just so you're aware of that. And you can use this schedule to know when all your final exams are being taken. So make sure you actually do that today probably, and start plotting out your next 5 weeks. It's going to go by faster than you would think. So just wanted to make you aware of that. So yeah, now hopefully we're all aware of that. As I've also mentioned before, and today's not going to be any different. Let me make sure I can see the chat and things of that nature. Okay. Okay. So we are going to, as we've done before, the plan for today is to just go through the quiz that you took on Monday. Make sure you guys can understand everything that you need to do, why you had to do it. And in the interest of time, we're already starting late based on all the announcements and everything. So in the interest of time, like last time, what I'm going to do, I'm just going to go through the quiz. I'm going to do the quiz. I'm going to explain what I'm doing, when I'm doing it, why I'm doing it. And if you have any questions, you can stop me every now and then. I'll check in to make sure you guys are listening, paying attention. That being said, I highly encourage participation. I've always encouraged participation, so be sure to do that. It would also be nice if you guys can like turn your camera on and participate if you're comfortable. I would highly recommend it. Before it's I didn't know how to control the camera on Zoom to make sure that only my camera gets recorded. But as I mentioned a couple weeks ago, I actually figured that out. So only my camera is going to be recorded. So your privacy is protected in that regard. So it'll be nice if I could like see you guys, make sure you're paying attention, or at the very least that you chime in every now and then. I will be seeing the chat. However, you know, if my head is down and I'm working on something, I might not see the messages as soon as they get sent. So I'd also encourage you to audibly say something if you want to actually stop me or chime in or have a question or that sort. So that being said, let's actually jump into it. Let's go through the quiz. Okay, so this is quiz number 4. And this is the first problem having to do with a straight line. So a line passes through these 2 points, -2, 3, x, -3, and it has slope -3/2. What is x? So here you're not told the x coordinate of the second point. You need to actually find that. And how you would actually find that
excuse me?
Yes?
I can everyone's can people see it? Because I can't see your screen at the moment. It just went black.
I can see the screen, no problem.
I can see the screen.
Yeah, I can see.
Okay, thank you. Yeah, as far as I know, there's no issue. It's also everything also looks okay on my end.
Okay.
So maybe you can log out and I'll log you back in. I'll let you back
that's
in
what
or
I'll do.
something.
Thank you.
Yeah, but everything seems okay on my end. And again, yeah, if any of you see any issues, just point it out to me. If you can't hear me, you can't see, just let me know. Okay, so what we do know is how to find slope. Slope of the line between 2 points we know is y2 minus y1 over x2 minus x1. Okay, and so it doesn't matter who you call what, but I am going to call this one x1, y1, and this one x2. Someone's coming in. This one x2, y2. Okay, and so now I'm just going to fill those in. We are told that the slope is -3/2. Y2 is -3. Y1 is 3. X2 is just x. X1 is -2, so it's minus a -2, so this becomes +2. So this is -3/2 is equal to -6 over x plus 2. I can flip both sides. or cross multiply, whatever you want to do. Then I would be able to multiply both sides by -6. So, I mean, 3 goes into 6 2 times. So this gives us +4 is equal to x plus 2, which means that our x is equal to 2. And that's this option right here. Okay, moving on to problem 2, which is a bunch of diagrams. So in the quiz, I didn't ask you guys to actually physically sketch something out. You may have to do this for a test, just be aware of that. However, in the quiz, all I asked you to do is either I give you an equation and you match it to a picture, or I give you a picture and you match it to an equation. So in this case, it is the former. I gave you the equation y equals x minus 2 all squared plus 4. You should recognize that as a quadratic. I want you to actually graph the correct one. To be able to graph it, you should be able to recognize that the vertex is going to be 2, 4. You should also be able to recognize things like the y-intercept. This just means x equals 0. So you'd have -2 squared plus 4, which is 8. Usually those 2 points you might be able to identify it. So for now, I'm going to stop and I'm going to look for who actually will fit that. So this has a vertex 2, 4. That has a y-intercept 8. Yeah, so that's actually the guy. Just to double check, this also has a vertex 2, 4, but the y-intercept is incorrect. This doesn't have the right vertex, so it's not that. This doesn't have the right vertex, so it's not that. Yeah, and it's none of the above. It actually fits in with the first one. Moving on to question 3. Here, I just asked you to solve a quadratic equation. And I believe the next problem, I also asked you to solve a quadratic equation. At this point, really, we should all be experts at this. So I don't anticipate too much trouble here. So we have 4x squared plus 10x minus 24 equals 0. Probably what I would do is divide both sides by 2 just to get slightly smaller numbers. Although it's not necessary, but you'd have to work a little bit harder without doing that. And now I would see if it factors. So it has to be 2x and x. Now I have to come up with 2 numbers that would give me 12. So it could be like 1 and 12, 3 and 4, 6 and 2, etc. But I need to make sure that the numbers will work together to get me a middle term of 5. So something like 3 and 4 looks like it might work because here, this outer part will give me 8x. This inner part here will give me 3x. And I can get to a +5 from the 8 and the 3. So all I need to do, this thing is blocking. Okay, all I need to do is make sure this is a +8 and a -3, and that would work. So then I would get my x is 3/2, or x is -4. Okay, and that's this. So that is question 3. Okay, to move over here to question 4, another quadratic. Okay, so I have y squared plus 16y plus 44 equals 0. Now I want to think of 2 numbers that when I multiply, I get 44. When I add them, I get 16. Nothing is coming off the top of my head. We can double check by prime factorization. This is 4 times 11, which is 2 times 2 times 11. So That's the prime factorization. How many ways can I break this up? Well, if I do it as 4 and 11, that doesn't give me 16. If I did it as 22 and 2, that won't give me a 16. There's not really any combination of these products that I can group into 2 parts to give me 16. So then I would just realize that this doesn't factor directly. So I would immediately jump into the quadratic formula. Y equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so now I have this huge thing under a radical, and technically we're not allowed to use calculators. So how would I actually look at that? Pretty much I would look at it this way. So this is 16 squared minus 4. Remember, my 44 is just 4 times 11. 4 times 4 is going to be 16. So this is 16 times 11. 16 is a common factor. I can factor that out. I would get 16 minus 11 on the inside here. So this is just 16 times 5. So I can go back here and realize that what I have here is 16 times 5 all over 2. The radical can distribute across the 16 and the 5. Radicals distribute across products. So radical 16 is 4. Radical 5 is, well, just radical 5. That doesn't simplify. And now I just divide the 2 into each part. So that's minus 8 plus or minus 2 rad 5. And let's see if that was an option. Indeed it is. Option B. So that was problem 4. Problem 5 is the opposite situation as to the earlier graph. Here I gave you the picture and I asked you to match it to an equation. And yeah, so here it's not really clear what the y-intercept is, although it looks like it's going to be around 9. So instead, I would just use the 3 points to identify this quadratic here. As the 2 x-intercepts, those look clear, as well as the vertex looks clear. So just to notice here that my x-intercepts are 1 and 3, and my vertex is 2 comma minus 3. Okay, so let's actually look at the options here. So immediately, we can actually get rid of some guys. This can't be, that can't be, because here the vertex is minus 2 comma 3, and here the vertex is minus 2 comma minus 3, so those can't be the case. Here, my vertex is 2 comma minus 3, and also here the vertex is 2 comma minus 3. So it's possibly A or B, or maybe even none of the above. So let's actually go further. What about something like the x-intercept? So for x-intercept, y equals 0. In fact, I can actually, in this case, it looks to me like even the y-intercept is not going to be clear. So y-intercept, if I plug in x equals 0, I would get 1. And the picture shown here clearly does not have y-intercept 1. So that this one is gone. What about this one? So here, let me check the x-intercept because the y-intercept actually isn't clear, but it's clear that it's not 1. So what I would do here is set y equals 0, and I want to solve for x. This means that 3 is equal to 3 times x minus 2 squared. This would mean that 1 is equal to x minus 2 squared. This would mean if I take the square root of both sides, plus or minus 1 is equal to x minus 2. And so your x would be 2 plus or minus 1. So that's going to be 3 or 1. And that actually fits. So there we go. Problem 6, we want to find the average rate of change of this function on that interval. We actually saw how to do this by a formula. So we do know here average rate of change on AB is, well, f of B minus f of A over B minus A. Okay, so that's the formula. And of course here, notice that the A is just the left endpoint. So this tells you here that your A is -1 and your B is 3. So this means what I care about is f of 3 minus f of -1 over 3 minus a -1. Okay. Okay, and so now I'm going to start plugging these guys in. So that's 4 in the denominator. In the top, now I'm going to have to plug in 3 into the function and minus plugging in -1 into the function. Our function is -x squared. So this is -3 squared plus 6 times 3 minus 8. This is going to be minus a -1 squared plus 6 times a -1 minus 8. Okay, so that's -9 plus 18 minus 8. This is going to be -1 minus 6 minus 8. 18 minus 8 is 10, minus 9 is 1. Minus 6 minus 8, that's -14, minus 1 is -15. 1 minus a -15 is 16. So that's 4. And that's that one. 4 is the average rate of change. I mean, on average, the y value is rising by 4 units every time the x value moves over 1 unit. That was Q6. Q7 has a bunch of pictures here. It's probably nicer for me to move that on another screen. These are remove a bunch of things if I'm able to use control on the keyboard. Okay, all right, there we go. So question 7, find the roots of the polynomial and then graph it. So here I ask you to graph a cubic, and we know how to find the roots. It means we have to factor, right? So I would factor out a common x. This should be like a -2 and a -3. So this means that the roots are x equals 0, 2, and 3. So automatically that's wrong. That's wrong. That's wrong. Ah, maybe. So it's either that or none of the above. Okay, so now, does the graph actually agree with that? Roots are 0, 2 and 3. Okay, so the roots do agree. Let's actually talk about end behavior then. So if I have x times x minus 2 times x minus 3, and I wanted to look at, say, end behavior, then I realized that it is, it was x cubed plus a bunch of stuff. In fact, that tells me that the right side goes up and the left side goes down. And so these two make sense. Now I want to make sure that the inside actually behaves. If, say, I plug in a value in between, say x equals 1, then my y would give me a positive number, a negative number, and a negative number. So overall, it's a positive number. So I should be above, which the graph agrees with. If I plug in x equals, say, 2.5, and I'm plugging into here, then my y is going to be, if I plug in a 2.5, that's a positive. 2.5 minus 2 is also positive. 2.5 minus 3 is negative, which means that's a negative overall. And so the graph should be below. So you'd realize that this graph fits all the features. So it actually is that guy. Has the right end behavior, the right roots. It's above the x-axis when it should be. It's below the x-axis when it should be. It's a very wavy function. It looks like the graph of polynomial. That's the guy. Okay, let's look for question 8. By the way, are you all with me? Everyone's following? Any questions so far? Did I say anything crazy out of the ordinary?
No.
Okay,
Everything's
so
good.
okay, everything's clear so far. Okay, cool. Let's keep going. Factor completely. So we're going to start with x cubed. And again, we spent a lot of time on factoring. So here you'd first look for the GCF. This has none. So the next thing I noticed, there are 4 terms, which my mind would automatically now gravitate to factor by grouping. Let's see if I pull out a common term from the first 2. I get that. I can pull out a -9 from the second 2, and I would get that. Now my x minus 2 is a common term. I can factor that out, and I would get this. And now I realize that that is a difference of squares. So that'll become x minus 3x plus 3. So that's the answer. That's factored completely. None of the above. You'll notice here that this part gives you that. However, the problem is it's not completely factored. You can actually go further. And so that's why that's not it. And the thing did say factor completely in all caps. So choice D there is incorrect because it's incomplete, not necessarily because it's just flat out incorrect. Okay, also have several pictures to move here. It's going to be nicer to move it on the other screen. So one, 2, 3, 4. What about the first choice? Oh, this is -3 all squared, right? So if I were to write this out, this would be x minus 2, x minus 3, x minus 3, right? But one of them have to be a +3. Yeah, so that's why the first choice wouldn't be the one. Okay. Moving on to problem 9. Here we are asked about find the slope, the y-intercept, and sketch. There's a nice form to write the equation of a line in that gives you the slope and y-intercept right away. I'd probably do that. So if I see this, I'm going to realize, well, that means at 3x, I move the 29 to that side and the 5y over that side. And then I can divide both sides by 5. So that tells me here that that guy is the y-intercept. And this guy is the slope. And so this checks out and that checks out. Anyone else? No, that doesn't check out. No, that doesn't check out. No, that doesn't check out. So it's either the first one or none of the above. Let's make sure. So what does the graph actually look like? I would actually make sure that it looks somewhat like that. Now, the numbers here, of course, they aren't super nice, but I would still try to find roughly what they are. So let me look at the intercepts here, right? So if I want the x-intercept, I set y equals 0, so that's 3x equals 29. So my x would be 29 over 3. Now that is going to be 9 point something, right? Because 30 over 3 would be 10. So 29 over 3 it's almost 10. It's right before 10. And we also know that the y-intercept is minus 29 over 5. This is almost. 30 over 5 would be about 6. So this is a little bit less than 6. So it's minus 5 point something, but it's something big, right? So minus 5.9, and the other one is like 9.9. So here, when I start counting this off, yeah, this is almost 6 because minus 6 is right here. And this here is actually 10. Notice that it crosses right before these guys. So yeah, this picture is pretty good enough. It's pretty spot on. That's my answer.
I have a question.
Yes.
Are you gonna put like the grades on Gradescope so we can see which questions we did wrong?
Did I not already do that?
I'm not sure, but I can't see mine. I can only see my grade on Jupyter.
Yeah, it's
Okay,
only
so
on Jupyter.
I meant to do that. So if I didn't, that was a mistake. So let me. I think I'll do that after class. So here, note to self.
Thank you. Sorry.
Send out grades on Gradescope. Yeah. Yeah. Sometimes when you're managing all these classes and responding to all these emails, things fall out. But yeah, I'll post that soon. I'll post that today. Okay, find the domain and range of the function. Okay. The next few sets of questions, I ask you all about functions in various contexts and various representations. However, hopefully, by going through the function definition, you can actually see what you would require. So remember, for intents and purposes here, range refers to the set of y values for which the function is undefined, which the function is defined. Domain refers to the set of x values for which the function is defined. You'll notice here that all y values from -1, right? So from y equals -1 moving up, that's the range, right? So the coordinate of this is, 0, -1, and then it keeps rising. So the y values, the y outputs keep getting bigger and bigger and bigger, right? So the range goes from -1 to infinity. What you can also see here is that the x values start at 0 because the graph isn't even on the left, and that continues that way. So this is the domain. So the domain is all x values from 0 or bigger, including 0, because that point is filled in. And the range is all values from -1 and bigger. So the domain is all things bigger than 0, including 0. The range is all things bigger than -1, including -1. That's choice C. One way we can represent functions I spoke about in class was as a list of coordinates. The important thing here is to just make sure that the guy in the left position is not repeated. And that's pretty much it, right? As long as you don't have that, you can construe the thing you have as a function. So what you will notice here in the first situation, we have 1, 3, -5, 4. This is actually okay. The second one is a problem. Notice here you have a 1 in 2 different positions on the left. Basically, this says that our 1, the output of 1 is -5, but also the output of 1 is +5. That's not a function. Oh, you missed the last problem? Sorry, it was this one. Domain is all x values for which the function is defined, and the range is the set of all y values. Thanks, Ariel, for confirming that. Okay, so that one's not a function. Looking at the third one, 2, 7, 3, 7, 4, 7, 5, that's fine. Nothing wrong there. 1, 1, 2, 2, 3, 4, 1. That's fine. Nothing wrong there. Oh, this guy 1 is mapping to 4 different things. Functions don't do that. For each input, a function will only give 1 output. Now, it does not matter if everyone gives the same output. So notice like in the third one, these guys are always 1. That's just something that we call a constant function. The output is always the same, meaning, for example, a horizontal line would be a function that behaves like that. No matter what you put as the x coordinate, you always have the same y coordinate. So there's nothing wrong with the second value being repeated. The problem with a function is if the first value is repeated. You cannot have the first value being connected to more than one things. Therefore, those 3 are functions and the other 2 are not. And here, another problem where there are a lot of pictures. So let me move that on the other screen. All right. Which of the following mappings represent functions? Again, you basically don't want an input having two different outputs. That's no bueno. Again, this guy having two different outputs. Here, everyone has a different output. Sure, -1 and 4 go to the same guy, but that's not illegal for a function. The important thing is that -1 only connects to one person and 4 only connects to one person. The fact that they connect to the same person is a non-issue. For a function anyway. There are other types of things. If I wanted a one-to-one function, for example, that would be an issue. But here, a function in general, in the general sense of the words, that's a non-issue. So that last one is a function. Oh, you like those problems? Awesome. Now, so that was seeing if you understand from a mapping diagram if something is a function. Now, these are actually graphs. Okay. How do you recognize if a graph is a function? So you're plotting on the XY plane and you want to know, is this picture I'm looking at a function? Then there's one criteria, right? So yes, you can refine this criteria for different kinds of functions. So you might want to know, is it a one-to-one function or an onto function? But you didn't actually need to know that here. But yes, as Chris Long mentioned, vertical line test is how you do it. If I just ask you about in general, is this a function? Vertical line test is how you would see. So here you just realize that any vertical line will touch the graph at most one time. It's possible that it touches it 0 times, but it must touch it at most one time, right? So that is the vertical line test. This one passes that test. This one does not pass the test. Notice that this vertical line goes through 2 points, not a function. Vertical line, any vertical line that I could draw in the XY plane will only touch this at most 1 point. That's a function. Similarly here, any vertical line I can draw will touch that at most 1 point. That's a function. Not a function, right? So here I can touch at 2 points, not a function. And you can say, yeah, but I can do that and touch 1 point. Doesn't matter. The vertical line test says any vertical line that you can conceive of has to touch it at most. So yeah, you might be able to find a particular vertical line that will touch it at 1 point only. However, if there is any vertical line that touches it at more than 1 point, it is not a function. Here we have the same x value giving us 2 different y values. Similarly here, I can draw vertical lines that will touch it in more than 1 places. Sure, this one here would touch it only in 1, but there do exist vertical lines that touch it in more than 1 places. So this is not a function. So the first one, the third one, and the fourth one were functions, and those are the only ones. So vertical line test, right? So just pictures, no calculations. It's just, do you understand the concept of what a function is, how it's supposed to behave, how the graph of a function is supposed to behave, etc. More testing about representations of functions. So here I have a table representation. We also spoke about this in class. Do you know how to read off the values of a function from a table? Okay. So here you'll notice that this is the x, that's the input. We know that x is the input, right? Because we have it here and here. And so these guys are the outputs. This is the output of f, and this is the output of y, right? So that's what we're going to do. And now we're going to put a couple things together. We're going to make sure that we can read from this table and we actually understand the notation. So now the first thing I want to do is find f of 1. F of 1, what does that mean? Well, it means I want to find when x is 1, what does f give me? And it's going to be that guy. Right, so there, that's the column where my x is 1. My f of 1 is 4. Also, I'd want to find g of 3. What does that mean? This means when x is 3, what is g? X is 3 in the last column. My g is 3. So this is just going to be 4 plus 2 times 3. That's 4 plus 6. That's 10. And we have a similar thing here, except again, we need to understand what this notation means. F of g of 1, that basically means f of g of 1, right? And so now, what is g of 1? Well, g of 1 is when x equals 1, the output of g, right? So that's minus 1. And what is f of minus 1? Well, this is, probably don't want any more crisscrossing arrows. Let's put it all the way around here. F of minus 1, you'll notice that when your x is 1 in the table, your f is actually positive 1. That option right here. So basically, it's just checking if you can read. And of course, to be able to read, you have to understand the conventions. So minimal calculations there. Just if you know how to read a table for a function, you should be able to do that. Here again, we're reading graphs. Several things there. Let me move that with the other screen. Actually, I think I can move even more. Okay, all right, there we go. So here are two functions and their graphs, and I ask you to find these guys. Now, as long as you remember what these notations mean, it shouldn't be too much of a problem. This basically just is notation for that. So I need to find f of 2 and I need to find g of 2. So I go to this graph. F of 2 just means on the x-axis, I pick 2 and then I trace it vertically until I hit the f. Then I trace it horizontally to see what the output is. So that is f of 2. I also need g of 2. Similarly, I would trace it vertically until I hit the graph of g, trace it across, it's minus 1. That is g of 2. So now this is just f of 2, which is 3, plus g of 2, which is minus 1. That's just 2. And that's that. Here I want g of f of minus 2. Remember, by notation, this is just g of f of minus 2. Now I want to know, what is f of minus 2? So I go find minus 2 on the x, trace it vertically, hit the graph of f, go across horizontally. F of minus 2 is also 3. So this is just g of 3. So now I have to go find g of 3. Right here, when I'm actually on the graph as it's on the x-axis. So the corresponding y value is, of course, 0. That choice right here. And that's that one. Okay. So that's for 15 based on reading the graph. So this is just, again, testing. Do you know how to read graphs, interpret graphs, and do you understand the notations? What does f plus g of 2 means? What does g of f of minus 2 mean. And if you know both of these ideas, you put them together, you can get that with minimal calculation. Here you'll need a little bit more calculation, but I want you to appreciate that this here is, again, just another way of writing g of f of x, right? And so here, this also is g of f of something. So it's actually the same function being used in both of these. So remember, whenever we want to reuse a function, I would recommend finding the answer in general first, and then you can just use that. But you could have found each of these directly. But what I'm going to do, I'm actually going to do part 2 first, find the general answer, and then all I would have to do for part A is to plug in 3 into that general answer. So remember, if I have g of f of x, this just means I go to g, and everywhere I see x, I replace it with f. So this is f of x squared plus f of x. So everywhere I saw x, which is here and here, I now replace it with f. So f is actually 2x plus 1. So it's that. Now, don't distribute powers across sums. This has to be, foiled out. So this is actually 4x squared plus 4x plus 1 plus 2x plus 1. This is 4x squared plus 6x plus 2. Option B. And in the other one, this is just g of f of 3. Well, that was actually computed before using above. Of course, you could compute this directly. You could plug in 3 into f and then take that number and then plug it into g. You'll ultimately get the same thing. So here, it's just a matter of plugging in 3 here and here. So that's 4 times 9 plus 3 6 is 18 plus 2, so plus 20. 4 times 9, 36. So that's 56. That's the answer there. Here's problem 17, the last non-bonus problem, right? So we made it here, even though we wasted a lot of time talking about stuff in the beginning. Yeah, we still made it here pretty comfortably. So I think it was a fair test overall. So just remember, for these guys, you have to do 2 things. Find what the leading coefficient is going to be. Coefficient is -3. And the important thing is that that's negative. So that's what you really want to realize. This here is negative. You also want to find the degree of the polynomial, the highest power. Remember, the degree, when you're multiplying out like this, because of laws of exponents, it's really just going to be the sum of all the highest powers. So highest power in the first factor is x equals x to the 2. Highest power in the second factor is also a 2. Highest power here is a 1. Highest power here is a 1. So the degree is 6. So this graph is going to behave like, so my y is going to be a -3 x to the 6 plus a whole bunch of stuff that I don't care about, because the end behavior doesn't care about them. So the end behavior from this, I know, because it's even, both sides would do the same thing, and because the leading coefficient is negative, both sides are going down, which means as x goes off to infinity, my y value will go down to -infinity, and as x goes off to -infinity, my y value will go down to -infinity. So that leaves me here. And that's pretty much the quiz. Now, let's suppose you wanted to do bonus problems. Some of you may have attempted this. Let's just actually knock these out pretty quickly. So you don't really had to do these, but the first couple should have been giveaways because I've tested you on this a couple of times, as well as the problems themselves aren't so bad. Circle has this equation. You just remember the general form for the equation of a circle: x minus h squared plus y minus k squared equals r squared. You know that h comma k is the center and r is the radius. Right, so in this case, on the right side, we have 36. If that's r squared, r must be 6. So I know it's potentially one of those guys. But then if I match up the centers, the center is 4 comma minus 3, and the radius is 6. That's that. Here, the point 4 comma y is 5 units away from that point. There are two possible values for y. Which one is the smaller one? So here, we're pretty much going to use the distance formula. So we know the distance formula, the distance between x1, y1, and x2, y2. That's just the square root of x2 minus x1 squared plus y2 minus y1 squared. So now I'm going to plug these guys in. So here, I'm just going to use x1, y1. Let's say I use that as 4 comma y. And then x2, y2, let's use that as 1 comma 3. Just because. Right. It doesn't actually matter who you pick to be who, you'll get the same answer.
My things keep dying.
I want some Enzo's pasta right now.
Me too.
Skylar, I think you unmuted by accident there. Anyway, let's actually continue. So here we're told that the distance is 5. So here we know that this is 5. And I'm going to plug in these things here. So my x2 is 1, my x1 is 4. My y2 is 3, my y1 is just y. So I have that. So what I can do here, square both sides. This would be a minus 3 squared plus 3 minus y squared. I can subtract, minus 3 squared is 9. So this is 25 minus 9. It's going to be 3 minus y squared. So that would give me 16. Square root both sides, I get plus or minus 4. So this means if I, move my y to that side to make it positive and move this to that side, this would give me y is equal to 3 minus or plus 4. So my y is either 3 minus 4 or it's 3 plus 4. So my y equals minus 1 or my y equals 7. This asks for the smaller one. Is that an option? It is indeed. So we have that. Was there another? Yes. A couple more. The points this and this line, the endpoints of the diameter of a circle. What is the center? Well, this is clearly asking for the midpoint. So we just want the midpoint of 3, 4, and minus 5, 6. Right? So we know this basically is equal to x1 plus x2 over 2 and y1 plus y2 over 2. Right? So let's just call this x1, y1, call that x2, y2. Again, just because on a whim, it doesn't matter who you pick for who. So x1 plus x2 all over 2, y1 plus y2 all over 2. So that's minus 2 over 2, and that's 10 over 2. That's that. Okay, so those are bonus problems, shouldn't have been too bad. This one, though, was not in the lecture up until the point, unless you watched ahead, up until the point you had to take the quiz. So potentially some of you didn't know about this, but again, it's usually something that a lot of you would have seen in algebra class. So maybe, I don't know, this is probably something that you could get. So the trick to these, when you have a piecewise function, the definition changes based on which part of the domain you're in. And so you just have to make sure that the input, which in this case is 4, you need to know which part of the function applies to that input. Notice that 4 falls in the interval of something that's greater than 3, because 4 is not equal to 3. It's also not between -8 and 3. It's something that's greater than 3. So this is the guy that takes effect. And so I would actually plug in 4 into that. And you'd get 0. Now, again, when you go to -8, you want to know which one of the intervals does -8 fall into. And you'll notice here, -8, x not equal to -8 anywhere. So it's actually none of the above. How we would say this would be undefined. The function is not defined for x equals -8. So you end up with here, none of the above. Can't be any of those answers. And I think that's it. Yeah, that's everyone. Okay, so that's that. So we are going to wrap up here. I think that quiz is okay. Again, just to remember, fill out the Doodle poll. I sent that out in an email yesterday, maybe. Make sure you can actually make it to one of those dates. Pay attention to the exam schedule, so go to the final exam schedule. I also sent you an email about that a while ago, 2-3 weeks, maybe even a little more. I don't remember. It's been a crazy semester. But make sure you do that. You start mapping out where your finals are. I will send out the Gradescope emails. I thought I did that, but apparently I didn't. And yeah, unless there are any questions, we are going to wrap up there. Yes, Ram?
Is our test 2 our final, or is it like test 2 then our final?
No, there's test 2 and our final.
Okay.
Which again speaks to this. When I said exam schedule here, I was mostly referring to my exam schedule. So if you go to the syllabus, all planned quizzes and tests and everything is there. So you'll notice that there is a test 2 and there is a separate date for your final. So we have 2 tests and the final. Yeah, make sure you know when those tests are. So look at my syllabus for my tests. Look at the final exam schedule that I sent you for the final exam. And you should be knowing when your other tests for all your other classes are as well. Remember, you want to be aware of all the important deadlines. Okay, that being said, I think we'll stop there. If you have any questions, let me know. Thank you for your attention and participation. Hopefully everyone is okay. Fill out the Doodle poll, and I might see you guys tomorrow or then based on how that goes. And for now, we'll end there. I will see you guys in the next one. Ciao.